Hello, I am Saurav and I will be diving into our final project for the CY 51 Introduction to Cybersecurity. So the project name of ours is the Enhancing Cybersecurity through Automated Vulnerability Detection. I am here with my colleagues, all from the Computer Science Department at the Southeast Missouri State University. So let's go through the table of contents. So these are the abstract background, the common vulnerabilities and exposures, then national vulnerability database details, which is also known as NVD, and then cybersecurity performance goals, challenges in implementing CPG, and then automated vulnerability inspection solutions, design of experiment, and then implementation, and then finally the final model outline, and then conclusion and the references. Let's go through the abstract first. So we are addressing the pressing need for better cybersecurity, especially as companies move forward to the remote work. So our focus is on a solution saying that automated vulnerability inspection. So this particular tool helps us identify weaknesses in our systems. We are using a tool called NMAP to make things simpler and more readable. So for the background, so as we know that in today's world, securing networks is difficult, right? And especially with the rise of remote work. So different platforms mean different risks, right? And it's also overwhelming to decide where to start. So we really need a preventative measures, but where do we implement them? That's the challenge we are tackling right now. So the common vulnerabilities and exposures. So what are these and what's going on actually? So there are, these are like a list of known issues and in software or hardware that can harm our systems, right? And we get the list from the NVD, the National Vulnerability Database. And it is a kind of library for vulnerabilities. It helps us to see where we need to focus our efforts on. Now I'll be passing the slides for Ms. Pavani to go through the rest of the slides.
In these slides, we will be going through the topic National Vulnerability Database details. Here, this database gives us the tons of information for each CVE, like a well-detailed report card. It even has a scoring system, CVEs, to tell us how severe a vulnerability is. So instead of individually testing each system, we can use the database to identify what needs to be fixed. And in here, we are going through cybersecurity performance goals. Now, to make things even clearer, we have the cybersecurity performance goals. It's like a checklist and a roadmap which helps us to identify, protect, detect, respond, and recover. It guides us on what to do, where to focus. And in here, we're going to through the challenges in implementing CPG. But here's the challenge. It's tough to figure out where the problems are in our network and what remote work. It gets even trickier. Each access point means a new set of risks. It's like a juggling of a lot of balls at once. Here, automated vulnerability inspection solution. Automated vulnerability inspection solution is like a detective tool for our network. It uses NMAP to identify those CVEs we talked about and shows us the result in a simpler way. Next slides will be presented by Prasad.
Hi guys, this is Prasad, and I will going to cover the design of experiment and the implementation part. So in this slide, we are discussing on the design. So we created a little network with the vulnerabilities and let AVI loose on it. It successfully found an outdated SQL Server vulnerabilities, knowing the problem is the first step to fixing it. In the implementation part, for tech savvies among us, AVI works on platforms like Kali and Linux systems. We wrote it in languages Bash and Python. The tool is our trade, NMAP and Python. So it's like having the right tools in a toolbox. Now we will discuss the final outline model. So what is an outline model? So AVI given an IP address does a NMAP scan, collecting loads of data. We save this in an XML file with the details like ports, vulnerabilities, references, etc. But the raw data can be overwhelming, so we can convert into a simpler CSV file for easy understanding. Yeah, this is the process flow what we have implemented. We have a Python project. In this file, we have given the list of IP addresses and we ran the scan command on the command prompt. It will scan the listed out IP addresses and gives the results. These results will be converted into a XML file. This XML file, the Python actually uses this XML file and it converts that and optimize the results and take the necessary columns and write those necessary columns into a Excel file. Say, for example, if any vulnerability has a CVE IDE, we will go into the CVE databases and we will look for all the CVEs and we will get the base scores, impact details, and their scoring systems like high, medium, low risk. We will write all those informations to CVE file. So now I can explain the code part, what we have implemented.
So in conclusion, we have found that automated vulnerability inspection is a key player in cybersecurity. So it helps us to see our network's vulnerabilities clearly and takes away some of the complexity. So here are the references that we have used to make the solution even more efficient and look better. And the contributors are Sai Pavani, Saurav Ghosh, Prasad Dama, and Lindsey Redington. And thanks.
All right, so for our project, we did automated vulnerability inspection. Basically what we did is we automated an NMAP scan and formatted an output. With our original code / program, we did it over just a singular NMAP scan. So I already did an NMAP scan and exported it to an XML on my virtual machine. And so with this program, we're able to format that NMAP scan that we've already created and get a better output. So by doing Python, running this one, you can see that we were able to gather more information on these specific CVEs. And whenever we go to our folder, we will see that there's a summarized scan results. We'll click on that. And then for each scan, which is usually executed by a specific script, it will give information including the port ID, protocol, service, script ID, CVE. Not all of them have one, but if they do have a CVE, this information is also included, the score, severity, complexity, and impact. Additional information is also included, such as like the title, state, which is vulnerable, likely vulnerable. There's one that says not vulnerable, descriptions, and references. So you can see when you zoom out, there are several of them, and depending on the script, you'll get different information. So say with this one, you can see all of the SQL injections. So those are all the options that you might be able to use, possible SQLi queries. So that's based off of just the one NMAP. Our other code we were able to select an interface and scan all of the IPs within that interface or network. So I ran this ahead of time because it takes so long. So I ran this, which XML to CSV detail is our network scanning. I first ran a command to get all of the interfaces and options. I selected this very first one, and you'll see later down it'll ask what interface. I put that down, and it scans the interface to find how many IP addresses. So this is all the IP addresses. This one takes around 15 minutes, so I just skipped that. That's why it says too long. And so from there, it scans each IP. So you can see the first one, second one, and so on. And you'll see that they executed successfully, and then it was put into a CSV file and then formatted into the Excel. When I go back to this folder, I can see these are all the NMAP scans. And you can then see the scan result, which because of how my local Windows is set up, it doesn't really obtain the vulnerabilities like you would if you didn't have all that set up. So with all these examples, there's not really any CVEs that are related, but this just shows how it's automated and how it does work when you scan a system. Formatted, you have this. So usually if there isn't any vulnerability, it'll just give you the port, protocol, service, and script ID. But yeah.